Welcome to day 4 notes. Today we're going to get into an introduction to identities. This is going to be one of the more important lessons to start this trig course. You'll be using these identities throughout trig and any higher level math classes you take after this. So in algebra, statements like 2x equals x plus x, which are true for any value of x, were called identities. We have 8 basic trig identities that you're going to want to memorize. Now it sounds like there's a lot, but they're going to be connections. All right, so the reciprocal identities we already kind of talked about. Those are the same thing as the reciprocal functions. Okay, because if you take 1 over sine, you're a reciprocal of the sine fraction. So that one's already basically done. And these equivalent forms are just cross multiplying and solving for a different trig ratio. Okay, these ones are going to be a little bit new. So tangent of theta equals sine of theta over cosine theta. Okay, just a quick reminder as to why that would be. If we look at our circle definitions, sine of theta is y over r, cosine is x over r. If you have a fraction divided by a fraction, that's the numerator fraction times the reciprocal of the denominator fraction. R's are going to cancel out. You've got y over x, which is the circle definition of tangent. So if you can remember the circle definition of tangent, you should be able to remember this ratio identity, and then the cotangent ratio identity is just the reciprocal of the tangent one. So that's going to be cosine over sine. Then the Pythagorean identities are on this blue box, cosine squared theta plus sine squared theta equals 1. So I want first, notice, that was a horrible highlighting job, but notice that we say sine squared theta, not sine theta squared. That's going to be two different things. So if you write sine theta squared like this, what you are doing is squaring the angle. I don't want to square the angle. I want to square the value of the ratio. So this is going to be wrong in almost any circumstance. We want it to be written like that. Same with cosine, tangent, and the rest of those. All right. So cosine squared plus sine squared equals 1 comes basically from the circle. X squared plus y squared equals r squared. And we know that sine is x over r, or excuse me, cosine is x over r, sine is y over r. So if I square both of those and then square the r squared, right, I've got this right here. Because these things are going to cancel. And I'm going to be left with x squared plus y squared equals r squared if I tried to cancel out that r squared. Okay, that was kind of a jumbled mess of an explanation, but all it is a circle equation. Divide everything by r squared. You get this. That is our cosine squared. That is our sine squared. And 1 is just 1. These are that exact same Pythagorean identity, just solve for cosine or solve for sine. And then these ones right here, the 1 plus tangent squared equals secant squared. That is another equivalent form. Okay, when you're solving for that tangent square, or when we have this tangent squared one, it's just taking this main Pythagorean identity and dividing everything by cosine squared. And this one would have been dividing the original Pythagorean identity by sine squared. Okay, there are a lot of ways to use these identities, and we have a lot of different forms of them, but they all boil down to the same basic things. If you can remember this one, you can figure out the rest. Okay, so there's a lot that you can memorize, but most of them you can figure out if you know a couple. All right, so some of these are going to be pretty easy for examples. Some of them might be a little bit more challenging. So use the reciprocal identity to find secant of theta if cosine of theta is square root of 3 over 5. Well, I know that secant of theta is 1 over cosine of theta. So that means secant of theta equals 1 over square root of 3 over 5. But like I said earlier, when you take a fraction divided by a fraction, because 1 is a fraction of 1 over 1, all you're doing is keeping that numerator fraction and multiplying by the reciprocal of the denominator fraction. Okay. Since these ones are 1 over 1 times, makes it pretty easy. Okay. It's a reciprocal identity. I could have just flipped that right away and been done. This is just all of the work that would prove that. Okay, so now we want to use the ratio identity to find tangent. I know that tangent of theta is sine of theta over cosine of theta. So tangent of theta is 2 over square root of 5 over 1 over square root of 5. I'm going to flip that bottom fraction up and multiply. Square root of 5 and the square root of 5 cancel each other out because that makes 1. So I have 2 times 1 over 1 times 1 gives us 2. Okay, these things cancel. 2 divided by 1 is 2. That one's, I think, probably the easiest example of the day. Okay, if I have cosine of theta and I want to find cosine squared theta, I just take that value and square it. Having it written this way is the key. Okay, this does not equal cosine of theta squared. Okay, that squared tells me that I'm supposed to be squaring that theta, which is not the case. So cosine squared of theta equals 1 times 1 is 1, 3 times 3, which is 9. So example 4, let sine of theta equal negative 12 over 13 and cosine of theta equal negative 5 over 13. Find cotangent of theta. Cotangent of theta is cosine of theta over sine of theta. So cotangent of theta is going to be negative 5 over 13 over negative 12 over 13. I'm going to keep the negatives with their respective numerators as I move these things around. So I've got negative 5 over 13 times 13 over negative 12. 13's cancel, the negatives cancel, and I'm left with cotangent of theta equals 5 over 12. Okay, that's, if you're like, I can't remember what the cotangent ratio is, but you can remember that tangent is sine over cosine. Do tangent, then take the reciprocal of it. That's how we get this other identity. Okay, so if cosine of theta, or we want to find cosine of theta if sine of theta is 4 over 5, and theta terminates in quadrant 2. So initially, ignore that part. We want to solve for cosine of theta. We're going to get 2 possible values. Okay? The one that I remember all the time is this one right here. Cosine squared of theta plus sine squared of theta equals 1. If I want to figure out what cosine is, I would have to solve this whole thing for cosine. Okay? I'm just going to plug in the sign that I know first and then worry about solving for cosine. So cosine squared of theta plus 4/5 squared equals 1. I didn't change anything. Okay, 4/5 is what sine is, and that sine's squared. So I've got cosine squared of theta plus 16 over 25 equals 1. Subtract 16 over 25 from both sides. I've got cosine squared of theta equals, well, 1 is 25 over 25. So I've got 9/25. Now to figure out what cosine is, I take the square root of both sides. So I've got cosine of theta equals plus or minus. There are 2 possible answers. The square root of 9 is 3. The square root of 25 is 5. So that one's pretty nice. So I've got 2 answers. Now is when I come back and check in which quadrant does it have to be in. So if I just think of this quadrant 1, 2, 3, 4, my cosine always has to do with my x value. So if the x's are positive, cosine is positive. So cosine is positive here in quadrant 1 and quadrant 4. I need to be in quadrant 2. Okay, that's my x value being negative. So that means cosine of theta, oops, sorry about that. That means cosine of theta, if I have to scroll all the way back down, bumped the wrong part of my screen apparently, has to equal negative 3/5, not the positive, because of the quadrant that we're specifying. Okay, all of these cosine and sine have 2 positive quadrants and 2 negative quadrants. Cosine is positive on the right, sine is positive on the top. All right. Now, cosine of theta is -1/3, and theta is not in quadrant 2. Find the remaining 6 trig ratios. Well, 5 others, I suppose. Again, quick picture. Cosine has to be positive over here and negative on the left 2. If it's negative, okay, it's in quadrant 2 or 3, but it's supposed to not be in 2, which means I'm in this quadrant down here. All right? So I could draw myself a quick picture. Here's my origin. Right? -1, 3. There's my theta. Cosine is adjacent over hypotenuse. All right? So if I want to figure out what this point here is, I just use my Pythagorean theorem. So I've got -1 squared plus y squared. I'm going to say y right there equals 3 squared. So 1 plus y squared equals 9. Y squared equals 8, which is 2 square root of 2 when you take the square root. So if this is 2 square root of 2, I can find my ratios quickly using that reference triangle. So sine of theta, opposite over hypotenuse, is 2 square root of 2 over 3. Cosine we already found, so I'm not going to write it. Tangent of theta, opposite over adjacent, is going to be negative. I made a mistake, didn't I? Since we went down here, this should also be a negative value. Okay? Negative, I missed that part, so I apologize. But my tangent is going to be opposite over adjacent, so -2 square root of 2 over -1, which is 2 square root of 2. Tangent is how I found out that I made my mistake. Because remember I said on the right, cosine is positive. On the top, sine is positive. Tangent is going to be positive when the signs of cosine and sine are the same. So up here, they're both positive, so tangent's positive. And down here, tangent's positive because sine and cosine are both negative, right? I know this is the quadrant that my triangle needs to be in, so tangent needs to be positive. So if I would have not had this negative sign, I would have had a negative tangent, which is wrong. So if you can kind of just think about moving to the right of the origin, cosine's positive. Moving up from the origin, sine is positive. And then top right and bottom left, tangent is positive. All right? So I've got a couple of them. Now I can use my reciprocal identities. So the reciprocal of sine is cosecant of theta. That's going to be -3 over 2 square root of 2. The reciprocal of cosine is secant of theta. So that's going to be -3. And cotangent is the reciprocal of tangent. So that's going to be 1 over 2 square root of 2. Those are the remaining 5 trig ratios. All right, so what did we cover in this lesson? Write a quick summary so you have a nice spot to look back on things. What things are you not 100% clear on? I know there's a couple pieces in there where I may have made it a little more confusing than you wanted. So write down something you're not sure on, and then next time I see you in class, we can go over your questions. Have a great day.